A simple fuzzy logic system implemented in LabVIEW. If you watch a previous video first, then this video will make a lot more sense. Here is an overview. There's the LabVIEW front panel, LabVIEW block diagram, LabVIEW fuzzy system rules, fuzzy system input-output relationship. Each of these will now be explained in detail. This LabVIEW program allows the user to select an input value, and the output value is calculated and displayed based on the fuzzy system. As described in the previous video, we have one input and one output. The input signal is defined with 5 fuzzy sets that are uniformly spaced between +10 and -10. The output signal with 5 matching fuzzy sets between -30 and +30. Notice that both input and output signals are truncated past the limits. These are the fuzzy set rules. A one-to-one mapping exists between the input sets and the output sets. This is called the system test and is very useful in visualizing the input-output relationships. This fuzzy system is created and stored in a small file. The fuzzy system file is loaded into LabVIEW. The fuzzy system controller implements the rules defined in the fuzzy system file. SISO stands for single input, single output. This program takes a crisp input value and produces a crisp output value, which is based on the fuzzy system. The front panel permits easy selection of a crisp input and displays the crisp output, and displays the rule weights for each set. Any problem reading the fuzzy system file will show up here. LabVIEW documentation on fuzzy control is thorough, but it takes some time for a beginner to work through it. Examination of example might be a quick and easy way to learn some details. Click on Help and then Find Examples, then search for Fuzzy Control. Select Fuzzy Exercise Car Backward Parking VI. You can run the VI. You can examine the block diagram to learn the names of the important components. LabVIEW Fuzzy Control is amazing in its flexibility and programming simplicity. This example will show you all you need to know in order to create a much simpler program in this video. The final part of the video will focus on the creation of this fuzzy controller. Select Tools, select Control and Simulation, select Fuzzy System Designer. A blank Fuzzy System Designer page will open. Add the input variable, enter the input variable name, enter the input variable minimum and maximum. Click on the plus sign to add the first fuzzy member. Each new membership function will be a triangle. Each triangle function is defined by 3 points. These 3 points can be changed by typing in new numbers or by dragging the corners. Other membership function shapes are also possible. This one is a trapezoid with 4 selectable corners. Give each membership function a name and a color. Continue adding all 5 input membership functions. Then create all 5 output membership functions. Click on the Rules tab. Click on Operate. Click on Pre-Generate Rules. Select these options for reasons that will be explained later. Select Center of Area, which will also be explained later. Make all input sets match the output sets for reasons that will be explained later. For example, in line 5, input set PP matches output set PP. Make that happen here. Now, why were these options selected for each rule? The matching fuzzy sets with matching rules along with those options create a linear relationship between input and output signals. This is a good starting point before making nonlinear changes. Nonlinear relationships can be easily created by modifying any of the numerous options. Detailed calculations in the previous video showed how an input of 9.84 resulted in an output of 29.52. This fuzzy program also demonstrates it. The Test Systems tab is also useful for showing the input-output relationship. Click on Rules. Click on Test System. Shows a linear relationship. Change the input value. Select a particular input value, 9.84, and notice the output values, 29.52. Save the fuzzy system file in a folder where the LabVIEW program can find it.